Hey guys, welcome to this channel. In previous session, we saw what is Amazon RDS and RDS encryption and security. So if you have not seen that video yet, you can see that from I button. In this session, I'm talk about Amazon Aurora. So without any delay, let's start the session. The exam is starting to ask you a lot of questions about Amazon Aurora. Now, you don't need deep knowledge on it, but you need it to know enough high level overview to understand how exactly it works. So, this is what I'm going to explain in this session. Aurora is going to be a proprietary technology from AWS. It's not open sourced, but they made it so it's going to be compatible with Postgres and MySQL. And basically, your Aurora database will have compatible drivers. That means that if you were connecting to your Postgres or MySQL database, then it will work. Aurora is cloud optimized, and by doing a lot of optimization and smart stuff, basically they get 5x performance improvements over MySQL on RDS or 3x the performance of Postgres on RDS. Not just that, but in many different ways, they also get more performance improvements. Now, Aurora storage automatically grows and think this is one of the many feature that is quite awesome. You start at 10 gigabytes, but as you put more data into your database, it grows automatically up to 128 terabytes. Again, this has to do with how the design is, but the awesome thing is that now as a DBE or a CIS ops, you don't need to worry about monitoring your desk. You just know it will grow automatically with time. Also, for the replicates, you can have up to 15 replica as while MySQL only has 5 and the replication faster. The way they made it, it's much faster. So overall, it's a win. Now, if you do failover in Aurora, it was going to be instantaneous. So it's going to be much faster than a failover from multi-AZ on MySQL RDS. And because it's cloud native by default, you get high availability. Now, all over, the cost is a little bit more than RDS, about 20% more. It's so much more efficient that at scale, so it's make a lot more sense for saving. So let's talk about the aspect that are super important, which is high availability and read scaling. So Aurora is a special because it's going to store 6 copies of your data anytime you write anything across 3 AZ. And so Aurora's made much as it's available, so it only needs 4 copy out of 6 for writes. So that means that if one is used down, you fine, and it only means you have 3 copies out of 6 needed for reads. So again, that means that it's highly available for reads. There is some kind of self-healing process that happens, which is quite cool, which is that if some data is corrupted or bad, then it does self-healing with peer-to-peer replication in the backend, and it's quite cool. And you don't rely on just on one volume. We rely on 100 of volume. Again, that's something for you to manage. It happens in the backend, but that means that you have just reduced the risk by so much. So if you look at it from a diagram perspective, you have 3 AZ and you have a shared storage volume, but it's a logic volume, and it does replication, self-healing and auto expanding, which has a lot of features. So if you were to write some data, maybe blue data, you will see the 6 copy of it in 3 different AZ. Then if you write some orange data, again 6 copy it in different AZ, and then as you write more and more data, it's basically going to go again 6 copy of it in 3 different AZ. The cool thing is that it's going to on different volume and it's stripped and it works really well. Now we need to know about storage, but you don't actually interface with the storage. It's just a design that Amazon made, and I want to give it to you as well so you understand what Aurora takes. Now, Aurora is like multi-AZ for RDS. Basically, there's only one instance that takes writes. So there's a master in Aurora, and that's where we'll take writes. And then if the master doesn't work, the failover will happen in less than 30 seconds on average. So it's really quick failover. And on top of the master, you can have up to 15 read replicas, all serving reads, so you can have a lot of them. And this is how you scale your read workload. And so any of these read replicas can become the master in case the master fails. So it's quite different how RDS work, but by default you only have one master. The cool thing about this read replicas is that it supports cross region replication. So if you look at Aurora on the right hand side of the diagram, this is what you should remember. One master, multiple replicas, and the storage is going to be replicated. Self-filling, auto-expanding, little block by little blocks. So now let's have a look at how Aurora is as a cluster. So this is more around how Aurora works when you have plans. How do you interface with all of these instances? So as we said, we have a shared storage volume and it's auto expanding from 10 gigabytes to 64 terabytes. Your master is the only things that will writes to your storage, and because the master you can change and failover. What Aurora provides you is what's called a write endpoints. So it's a DNS name, writer endpoint, and it's always pointing to the master. So even if the master fails over, your client still talk to the writer endpoint and is automatically redirected to the write instance. Now, as I said before, you also have a lot of read replicas. What I did not say is that they can have a auto scaling on top of these read replicas. So you can have one up to 15 read replicas, and you can set up auto scaling such as you always have the right number of read replicas. Now, because you have auto scaling, it can be really hard for your application to keep track of where are your read replicas, what's the URL, how do I connect to them. So for it, you have to remember this absolutely for going for the exam. There is something called a reader endpoint, and reader endpoint has the exact same feature as a writer endpoint. It helps with connection load balancing, and it connects automatically to all the read replicas. So anytime the client connects to the reader endpoint, it will get connected to one of the read replicas and they will be load balancing down this way. Make sure just notice that the load balancing happens at the connection level, not the statement level. So this is how Aurora works. Remember writer endpoint, reader endpoint, remember auto scaling, remember shared storage volume that auto expand. Remember this diagram because once you get it, you will understand how Aurora works. Now, if we go deep into the feature, you get a lot of things I already told you: automatic failover, backup and recovery, isolation and security, industry compliance, push button scaling by auto scaling, automated patching with zero downtime. So it's kind of cool that emerging they do at the backend. Advanced monitoring, routine maintenance, so all these things are handled for you. And you also get these features called backtrack, which is giving you the ability to restore data at any point of time. And it actually does not use rely on backups, it relies on something different. But you can always say I want to go back to yesterday at 4 p.m. and you say, oh no, actually I want to do yesterday at 5 p.m. and it will work as well, which is super neat. For security, it is similar to RDS because it uses the same engine. We have Postgres and MySQL. So we get encryption at rest using KMS. We have automated backups, snapshots, and replicas that are also encrypted. Encryptions in flight using SSL. This is the exact same process we have for MySQL and Postgres if you wanted to enforce it. And we have also authentication using IAM tokens, which is the exact same method we have seen for RDS. Thanks to the integration with MySQL and Postgres RDS. You are responsible still for protecting the instance with security groups and you cannot SSH into your instance. So Aurora security all in all is the exact same as RDS security. Now let's create an Aurora database. So we will use standard create to have all the options available to us and we will choose Amazon Aurora. So we have two editions of Aurora. We have Aurora MySQL compatible edition or Aurora PostgreSQL compatible edition. For this, I am going to use Aurora MySQL compatible edition because there are more features to show you. So first of all, the capacity type. We will see some advanced feature in the next lecture, but we can have a look at preview at them in the session. So we either provision and we manage the server instance size, or we have serverless and then automatically Aurora will scale the capacity based on the database load, which is great option for intermittent or unpredictable workload. So to keep things simple, I'm going to use it as provision because it does give us more option, but serverless is quite a heavy feature. Then we have replication feature, and currently we have single master, which is what I told you that we can write only to a single writer instance, which is good for general purpose option for most workloads. Okay, but then if you have multi master, you're supposed to write to multiple writer instances, and this is good when you have continuous writer availability that is required. Now to keep it with many options as possible, I'll keep it as single master. Next, we have the engine version. As you can see, we can choose from 53 version right now, and we have different version here, but each version supports different kinds of features. And actually, there is some filter. So if you use this filter, you can say, hey, I only want see versions that supports the global database features, which is to span an Aurora database across multiple areas, region, or we want to only show version that support the parallel query features and so on. So for this, I am going to just show versions that support the global database feature and choose whatever Amazon Aurora recommends for me. So I'll choose this one, for example. So next I'm going to scroll down and we have different templates. So production or dev test. As you can see, there is no free feature for Aurora. So we will use production and see all these features. So the database identifier is going to be database 1. Then the username is going to be admin and the password again is going to be password. So let me enter a password. Then I'll scroll down, and here we choose the database instance classes. So we have memory and bus table classes, where we're trying to keep the cost as low as possible. If you want to follow along, so choose a dbt3 small with me, which is the smallest instance that you can have right now. But again, if you go ahead and create a database, just make sure that you are going to incur some cost. Next, for availability and durability, so do you want to create a multi-AZ deployment? And obviously this is best practice, so you can say no, I don't want to have an Aurora replica, or yes, please set up an or a replica or a reader node in a different AC, and I am going to do it, which is recommended for scaled availability. This is going to give you fast failover and high availability, but of course it's going to cost you more money. No matter what, if you don't use an Aurora replica, just know that your storage layer is no matter what replicate across 3 AZ. That's guaranteed. So I will choose to create an Aurora replica. Perfect. Then a VPC or subnet group. We want to make it publicly accessible. Yes or no? I'm not going to access it, so I'm going to say no. Next, a security group. I'll select a new security group. I'll call it Demo Aurora MySQL, which is all again on port 3306. We have additional options, which is just specify initial database names. For example, MyDB. Sometimes it's our group, which is out of scope. Failover again, it's out of scope. Backup is just how many days you should retain groups for this instance. So 1 day is good enough, but you all the way is to 35 days. Do we want to encrypt the database? Yes, and with what key? This one is perfect. Do we want to backtrack this database quickly in point of timing? In which case you need to say yes, I'd like to enable backtrack for my database and say up to 72 hours. I want to be able to backtrack back in time, but you can disable it as well. I will disable it. Do we want to have an enhanced monitoring? Do we have a more granularity on your monitoring? Yes. What do you want to do with the logs? Do you want to send them to CloudWatch logs? Yes. Maintenance window, we know this, and whether or not we want to enable deletion protection. This time I will disable this. Now let's create this database. It's going to take a little bit time, so I'm going to pause the video while it's happening. So now my Aurora database is created, and as you can see, we have regional cluster with a writer instance and a reader instance. So here the important fact is that we have different instances to write and to read from, and they are in different AZ. So this is the whole power of Aurora. So if you click on database 1, as you can see, to connect we have two endpoints. We have a reader endpoints and writer endpoints. So these endpoints are very handy because they represent an endpoint that will always lead to the right reader instance or writer instance, and these endpoints will always lead to the right reader instance. So these endpoints is what your application should be using to connect to Aurora. But if you were to click directly on this specific instance right here, this instance will have also a dedicated endpoints, and that instance over here would also have a dedicated endpoints once it is being created. So it's all being in the creating space. So we have these features that are cool. We have other features, so we can add more readers into our reader cluster to add on with scaling capacity. And we can also create a cross region read replica. If you want to have a replica in another region, we can restore any point in time. And another one is that we could add replica auto scaling. So this one is very important because, well, we can create a policy, and this policy would say, hey, based on the average CPU utilization of your Aurora replica or the average number of connection to your Aurora replica, then scale your read replica. So say read replica scaling policy, and say I want you to make sure that my replicas stay at a target value of 60%. And if I go over, please create more read replica. We could also define a scale in period for discovering policy, which makes sense, and what's the minimum and the maximum capacity. So one replica up to 15 Aurora replicas, and this is very handy to have read replica auto scaling as a database. So I cancel it. We don't need it right now. And now I have made sure that both my database and endpoints are available, so we are good to go. So one last thing I can do to show you the whole power of Aurora is to do action and add AWS region, and this is only possible if you choose a version of Aurora that was enabled with the global database feature. But here we can add the database region to other region, and this will allow you each get a global Aurora. Now as you can see, this is not possible with this cluster because we need to have an instance with a compatible size. To do this, first I need to change the instance, for example, to a large type of instance, and then we would be able to add other region to database cluster. But anyway, I wanted to show you the features right here. So that's it for Aurora. I really like this offering from AWS. Now to be done with this hands-on, just take this database and you want to delete it, but as you can see, it's not available. So you need to delete the reader instance first. So type it delete me. Then you need to delete the writer one. So again, action delete, and then you type delete me. And then once both of these things are deleted, you are going to be able to delete your whole cluster. So that's it, my database is now deleted, and I will see you in the next lecture. So if you found this video helpful, then share this video to your friend and stay tuned for upcoming AWS technical video. Thank you for watching. Bye and have a nice day.